Hi, I'm Scott. Today on GoldwingDocs, you got questions, I got answers. Coming up next. My gosh, it is hot in here today. It's, my thermometer says it's 88 degrees in here, and I'm definitely feeling it. So I've had several requests to do a Q&A type segment where instead of talking about one thing, I'm specifically answering questions posted in the GoldwingDocs forum. Actually, one of these actually came from a YouTube post, and somebody posted a question in the comments. But I have 3 questions. The first 2 I got were electrical, so I thought, well, I'll do 3, and so I picked the electrical one for the third one. So this is the electrical Q&A. 2 of these apply to all Goldwings, 1 is just for 4-cylinder Goldwings. All right, let's get on to the questions. The first one, I have a problem with my GL1500. Okay, I have a problem with my GL1500. It was running fine, and then I went out to ride it, and when I pushed the starter button, everything shut off. Okay, so that's actually a fairly common one. This actually applies not just to motorcycles, it applies to cars and pretty much anything that has a battery and an engine that starts with the battery. So what happens is you turn on the switch on your motorcycle, everything comes to life, the lights come on, it looks like it's ready to go, everything's working fine. The instant you hit the starter button, poof, it's like somebody turned the lights out. Everything's dead, bike's dead, you can turn the switch, you get nothing. Absolutely, the bike has completely died. This is actually a really simple problem. What's happened is you've got an intermittent or a partial connection in your battery system. So it could be a loose terminal on your battery. It could be a loose ground where it connects into the frame of your bike. It could be a failing wire. So basically what happens is you've got an imperfect connection between 2 pieces of metal. Maybe the battery terminal is loose, so it's not quite connecting, but it's almost there. It could be corrosion inside the battery cable itself. So you have enough of a connection that it lets through. When you first turn on the switch, it's pulling, maybe 6-7 amps. So it's got more than enough connection to pull 6 or 7 amps through. But the instant you hit that starter button on your bike, it's now pulling, it could be 100 amps. And the tiny amount of connection left isn't enough to pass that amount of current. It actually burns it and vaporizes it and turns it into oxidation. And that is like just turning a switch off. So now you have no connection, bike dies. So the way we fix that is find out where the problem is. Take your voltmeter and measure between the battery and the end of the battery cable, from the negative terminal in the battery to your ground point. And sometimes it's as easy as taking the battery cable and just wiggling it. If your bike comes back to life when you wiggle that battery cable, then you know you found the source of your problem. It's either a loose terminal or sometimes the battery cables where you have the terminal and it clamps onto the wire, and that can get loose and get corrosion in there, and that can be the cause of it. And in that case, your solution is to replace the battery cable. So hopefully that you're not stranded too long, and that will get you going. Next question. My battery shows a full charge of 12.7 volts, but it won't start the bike. Okay, so that's similar to the first one. The difference is you turn on the switch, everything lights up, it's all working great, but you press the button and maybe all you're getting is a click. Or maybe it's just like, and you barely turn in the engine, and everything goes dim when you do that. But when you let go of the switch, it all comes back to life. It's not dying like our first question. So what causes that? The easiest way to determine if this is the problem is to put your voltmeter across the battery terminals. And what you want to do is actually measure the voltage between the positive and negative right at the battery. And it should be 12.5, 12.6, 12.7 volts at the battery when the bike is off. So you turn the bike on and it's going to sag a little bit. You might see 12.4, 12.5. I mean, no more than a couple tenths of a volt when you turn the bike on. However, when you hit the starter button, you don't want to see that down. I mean, ideally not much more below 12 volts. At the absolute most, 11.5. If it's going lower than that, if you're seeing like 6 volts, 5 volts, the problem is your battery. So what happens is you get a battery and maybe you put it on a charger for a long time, or you neglected it and didn't have it on a battery tender. By the way, use a battery tender on your bike, like I've got right here. It will save you from having to buy batteries all the time. I'll put a link to it in the description below. So maybe you haven't taken care of your battery just quite as well as you might have, or maybe the battery's just old. What happens is you have these plates in the battery, and you have electrolyte between the plates. So these metal plates and the electrolyte between them is what causes the battery to make electricity, to say it as simple as I can. Now, if you mistreat the battery, the plates get what's called sulfation, which is a coating on the metal lead plates, and that limits the amount of current that the battery can generate because it only generates current on the plate that is exposed metal. So if you have sulfation covering part of the plate, that part of the plate can't be used to generate electricity. Now what happens is the battery still has 6 2-volt cells in it, so it's still going to produce 12 volts like a lead acid battery should. However, the current capacity of the battery is limited by the area of exposed plate within the cells. So if you limit that area, the current capacity of the battery goes down. So it has enough current capacity that when you turn the bike on, it has enough capacity to generate enough current to power the headlights and maybe the radio and whatnot. And because it has enough current capacity, the voltage stays steady. Now what happens if you start drawing more current out of a battery than it can supply? The voltage drops. So if you hit the starter and you're trying to draw 80, 100 amps out of it, and it can only supply at the most, say 20, well, the voltage is going to drop. And that's why when you press that and you see the battery drop down to 6 volts, okay, you've got a bad battery. So number 2 question, the answer is if measure your battery like I explained, if you're seeing the battery voltage drop, time for a new battery. Okay, number 3, this is for GL1000, GL1100, and GL1200 owners. Technically, it could apply to other Goldwings as well, but we don't typically see this problem in the other Goldwings. It's primarily the 4-cylinder wings. So this member has a voltmeter on his 1100 so that he can watch and make sure the charging system's working okay. The problem is that instead of charging at 13.8 volts, between 13.8 and 14 volts, which is where the battery should be charging when the bike is operating normally, he's seeing 15 and sometimes even 16 volts depending on the RPM of the engine. That's bad. That will destroy your battery. You can't be charging your battery at that high voltage. It will hurt the battery, it will sulfate it, it will boil off the electrolyte, it will definitely shorten the life of your battery. So what's the problem? Why is this happening? Well, the regulator in the 4-cylinder wings is not part of the stator. It's not like a car or a 1500 or 1800 where you have an alternator. And the alternator, the front half is the stator and the back half is the regulator, and it's all built into one piece. In the 4-cylinder wings, the stator is inside the engine and it has a permanent magnet that rotates inside it. It generates power, it comes out through those infamous 3 yellow wires, and then goes to the regulator. The regulator watches the voltage, and whatever is generated from the stator that it doesn't need, it just dumps it. And that's why it gets so hot, because it's just getting rid of energy that it doesn't need. The problem is the sense wire on the regulator. There's a black wire that in Honda parlance, every time you see a black wire, it is switched ignition. So switched 12 volts. Kind of like red is always on 12 volts, green is always ground. That's kind of a Honda thing. So there's a switched 12 volt wire that comes from the battery through the fuse box, through the ignition switch, sometimes through relays, depending on the bike, and then eventually it makes its way to the regulator. The regulator sees 12 volts come on there and says, oh, time to go to work, and it turns on. That's not all it does. It also watches how much power, what kind of voltage it sees on that black wire. And so if it sees only 12 volts of that wire and it says, I need that at 13.8, it boosts the output that it's sending to the battery to start charging the battery up so the voltage comes back up. The problem is these older bikes, there's lots of connectors and switches and things in between the battery through the switch and to the regulator in that black sense wire. And each of those little connectors and things, as they oxidize, they get a little bit of resistance and they drop the voltage by, maybe a half a volt, a couple tenths of a volt. But when you add them all up, you can drop your voltage by 2 or 3 volts. So even though the battery may be fully charged and it's seeing 13.8 volts, by the time it gets around to the regulator through that long black wire, it may be only showing 12.2. So the regulator says, I need to boost that up, so it cranks out more power, but it's already doing 13.8. So now it's 14, 15, 16 volts. And that's where the problem arises. So how do we fix that? Well, you can take the bike apart and clean every switch, every connector in between, but there is actually an easier way, and this is how I fix it on mine and how I recommend most people do it. All you need is a 12-volt automotive relay. I'll put a link to one in the description below. If we look at the circuit diagram here, we put the relay in place of the regulator on that black wire. So the black wire, instead of feeding directly into the regulator like it used to, we have the black wire feed the coil of the relay. And the other side of the coil, we just connect to ground. So now what happens is when you switch your bike on, instead of turning on the regulator, it just clicks that relay on. Now the output side of the relay, the business end where the switch is, we connect that between the red wires on the regulator and where the black wire used to go, like you see here in the diagram. And the reason we do that is because those red wires are connected directly to the battery. It has a really good idea of what the battery voltage is because it has a direct shot right there. So now you turn your switch on, it closes those relay contacts, and it sends that exact battery voltage directly into the regulator, into its black wire. And now the regulator has a realistic view of what your battery voltage actually is, and it adjusts its output appropriately. And that will fix your problem. Well, that's it for this video. I hope you liked what you saw here. If you have questions like this, go ahead, post them either down in the comments down below, or better yet, go onto the GoldwingDocs forum and post them there, because that way everyone gets to benefit from the answers that we come up with. If you like what you saw here today, please don't hesitate to click like, subscribe, and ring that little bell down below. Leave a comment or two. I always read all the comments, and I usually answer most of them. Thanks for watching.